Hello IB. We want to continue our journey looking at circles. So we've looked at angle measurement in degrees and radians. We've looked at how to calculate arc lengths and areas using both degrees and radians. What we now want to do today is start looking at a circle on the coordinate plane. So here we've got our circle, and it could be anywhere on our coordinate plane. Let's finish it off there. And we want to come up with an equation. So our equation, if we have this circle with a centre here and coordinates of A, B, and we'll give it a radius, nice straight radius of R. So if that's our circle, then we can write an equation for that of x minus a all squared. So this should start ringing a bell with transformations. So we're doing a shift in the x direction of a units plus y minus b all squared. So that's a shift in the y direction of b units equals r squared. So that's the radius squared. So in our particular case, what we want to do to make things easier is to have our circle centered on 0, 0. And we're going to choose a radius of 1, because that's going to allow us to make up a whole lot of relationships and see how we can relate the angle with the point on the circle. So if our centre is 0, 0, then our equation becomes x squared plus y squared, because a and b are both 0, and our radius is 1, and 1 squared is 1. So the equation for this particular circle is x squared plus y squared equals 1. And we call it the unit circle because it has a unit radius, 1 unit of radius. When we want to measure angles, we're going to measure our angle from the x-axis going anti-clockwise. That's just a convention. We needed to start somewhere. It's a little bit frustrating in that with bearings we start from north and go clockwise. But for angle measurements in the circle, we always start with 0, 0 and our point on the x-axis and moving that direction around our circle for positive. So here's our point. So we could get our points anywhere around the circle by moving anti-clockwise. We can still move anti-clockwise, but that will give us a negative angle. So if we're going backwards, we get a negative angle to say some point over here. We're going to go backwards through that angle to get to there. So you would have remembered, yes, with the other work we were doing, here's our point going around a circle. We have our positive values. So here's our angle up here, theta, positive. And if we move further around the circle, it increases in degrees all the way around to 90. If we put this into radians, we're at 0.83 radius, so we're not quite at the same arc length as the radius. Getting closer and closer, and there's 1, just a bit over 1. So in other words, that arc length is the same as the radius. So 1 radian. And remember what happens at 60? We get pi on 3. So at 60 degrees, it's pi on 3. But at 1 radian, remember that was just a little bit less, is about the 57 degrees. All right, so that's our angle measurement. And we move these images on the side. Good. All right. Come back. All right, so let's now see if we can work out some coordinates for our point. So if we want to deal with a point around the circle, what you're going to find is you're regularly going to be putting a right angle triangle into the circle, because our coordinate points are obviously our measurements of x and y. So our a value is going to be straight down here to the x-axis. It tells us how far in the x direction, and our y value is this far along in the y-axis. So remember, for a cos theta, we want adjacent over hypotenuse. So in our unit circle, our adjacent length is A. Our hypotenuse is 1 because we've chosen a unit circle. So in other words, A is the value for cos theta. So the cos of this angle matches the x coordinate here. So we're going to be able to write this as a coordinate of, there's P, cos theta. If we take cos of the angle, that will give us the x coordinate. Sine is opposite over hypotenuse. And if we look at our triangle, our opposite side is the b coordinate. So that's going to be b over 1, which equals b. So now we can find out the coordinates of our point by, oops, mistake, not thinking, well, try again. We want sine theta. So the coordinates of our point AB going around the circle can be calculated by cos of the angle and sine of the angle. So that's summarised in this picture here. So cos theta sine theta, where theta is the angle, that will give us the coordinates of P, and that doesn't matter whether it's in degrees or radians. So here, our cos theta gives us our x value. So there's our triangle back here, and that's a nice positive number. What we see here, when we take sine of theta, because our angle is all the way around, we can see it goes all the way around here, then our y value is actually negative. So we're going to find that a negative sine value means we're in a negative y value. So it's going to be somewhere down here, our y coordinate will be negative. Tan theta, remember tan is opposite over adjacent. And we can see now that our opposite over adjacent is going to match, opposite is sine theta, the y value, over adjacent is our cos theta. So we can get tan theta by sine theta over cos theta. So you can see where that relationship is coming from now, if you've heard of that before. We also would be nice if we could, if we think about that line, remember the tan theta is the gradient of the line, or the slope of the line. Of OP. O is the origin. All right, so it's that slope. If we draw a tangent, which is not just coincidence, from the edge of from when x is equal to 1 and we go straight up here to where the line joins, we can see that this height here is equal to tan theta. It's the opposite over adjacent. So the opposite is going to be this measurement. The adjacent is 1 because we've chosen it to be at the point where x is equal to 1. So that height here now is tan theta. Next thing is just to remind you, this is what you would have come up with on your plate. So you've got all those angles measured in. So what we're going to be doing in this section of 8C is all the time thinking about how can we get the coordinates of the point, and all the time we're going to be thinking about that triangle back here. All right, there's the right angle triangle. It gives us the x value here and the y value back over here. So this triangle here, we're going to think of our 30 triangle or the 30-60 triangle, and we know that if that's 30 degrees, then we'll remember that this is 60 degrees. Okay, so we can get sine theta and cos theta to work out the coordinates of this point. Or we might be dealing with this one over angle over here. We want to get the x coordinates and the y coordinates. So every time we're going to be drawing a triangle back to the x-axis to get our x coordinates and our y coordinate from over here, which is the height of here. So it's all to do with the angle. So see how we're going to be looking at this angle, even though for our point, if our point is up over here, oops, if we're putting our point up at here on our circle, because our point's moved all the way around the circle, so our point has moved all the way around to here, 120 degrees, or 2 pi on 3, when we come to work out the coordinates, we're going to be using this angle inside. And we often refer to this angle in here as our reference angle. What's it to do with in reference to the x-axis? We're going to again look at another point that might move all the way around the circle, all the way around here, let's say to this point. So let's say our point has moved all the way around from, it's going to get quite messy, all the way around to here, all right? But where do we draw our triangle? We want to look at our x and y coordinates, so we're going to come back here, to our x-axis, and this is our right angle triangle in here. So we're going to consider that triangle always going back to the x-axis. And if we want to look at the angles within there, where's our reference angle? This is our reference angle back here. All right? Always the angle back to the x-axis will tell us what angle we're going to look at to take our cos theta, sine theta to get the angles for that. So that's the first thing we'll probably do when we get to class, is look at this example where we've got 4 different points around the circle. We want to get the exact coordinates in terms of sine and cos, and then around 1. So thanks for listening, and if you've got any questions, bring that to class. Hope you have a good day. Bye for now.